All right, so today we're going to talk about absolute functions. And so our essential question is, how can I graph and transform, which just means move, absolute value functions? So you're going to see how we graph them.
Exactly. So an absolute value function, well, it's exactly what it says. It's a rule that contains an absolute value expression. We've used that in the last section. Now the graph, what an absolute value function looks like, it actually looks like a V.
Yeah.
And you're going to have the vertex is going to occur at 0, 0. When
you had X.
Right. When you're when you're talking about this right here, if this is truly your parent, which is your parent, is your parent
That's
function.
Your original function.
Yep.
Before you do stuff to it.
That will always have a vertex at 0, 0 and make a V.
Okay.
All right. So now, if we go down to here, I'll let Miss Boyd talk a couple things.
So if you're looking at this, so this is our parent function, the f of x. And if you add something or subtract something to the outside, it's going to have it go up or down. So if we're adding, it's going to move it up. If we were to subtract k, it would move it down. Horizontal is now on the inside with the parent function. So see how here it was on the outside, we added it after. Here it's in there. And now this one's tricky. It's opposite of whatever the sign is. So it says horizontal, so that means we're going to be going either left or right. But we do the opposite. So if it says negative, which normally you would think would move left, it actually is going to move to the right. And then if we would have added h on the inside, this time it would have moved to the left. So just remember, if it's on the inside, it's going to be the opposite of the sign.
Right, exactly. I want to point something out because I just realized as we were starting, there is a typo in these notes that they're already at printing. So I would like you all to change something here. It's not absolute functions. I forgot the word absolute value.
That's what I was wondering when I was saying
yeah, so I apologize. So if you could please go change that in your notes because that is a typo.
Perfect.
All right. So are we ready to move on?
Yeah.
Well, gee, look at that. Let's go on to our first example already. So it's saying, I don't know, we didn't really talk about what it means by transformation yet, did we really?
Yeah, we said it means to move.
Okay, thank you.
Yeah.
So notice, typically when Miss Boyd and I talk about this, the parent function is always the f of x function.
Yep, so that's what I just wrote, the original.
Right. The transformed or changed function, we're going to call g. We're just calling it a different name. It could be h, it could be q, it could be l.
It's just a different one.
It's just a different one. Right. So it's saying, let g of x be the indicated transformation of f of x.
Okay.
We're going to write the rule. Could you underline that or highlight that? Because write the rule.
Changing the original.
Right. And the directions you're going to see all the time on quizzes and tests and everything. It's going to say write the rule for g of x.
Okay.
Which means you're going to create a new function. Exactly. Okay. Notice we're going 4 units down.
Down.
So up or down means something's happening on the outside of the absolute value.
Yep.
So we're still going to use the absolute value of x. That's not going to change at all. And it's going to be -4.
Yep, because down means minus when it's on the outside. So -4.
There is the rule. When it says write the rule, that is it.
That's our answer.
So maybe write rule underneath that, just so they can add that to their notes.
Okay.
Now let's graph.
Okay, so I'm going to graph the original.
Yep, let's do that. Should we do that in red? Okay. Yep. We're going to do our best here.
Yeah.
And notice when it says it's moving 4 units down, the vertex is moving down 4. So we count 1, 2, 3, 4.
Put our dot.
Right.
And then keep the same shape.
Right. And you don't have to, it doesn't have to be any more scientific than that.
Perfect.
And now notice the vertex, let's maybe right next to the blue graph.
Yeah.
What's the vertex for that new graph?
Oh, the new vertex?
Yeah.
Well, we didn't go left or right, so it's still 0.
Yeah.
But we went down 4, so -4.
So the red vertex is still 0, 0, and the blue one's 0, -4.
Got it.
Okay. Let's go down to example number 2. Notice the same thing. It's saying perform the transformation, then graph. It doesn't say write the rule here. So I threw this at you because you're going to see kind of all different sorts
ways.
of, Okay. Whenever it says perform the transformation, you are creating a new function.
Okay.
You are writing a rule.
So we're taking the original, changing it. This time it says 2 units to the right.
So we're changing what's
right
inside.
is on the inside.
Right.
Which means we do the opposite. So normally you would think right would be negative.
Right.
But we got to have it positive.
Right.
So here's our parent function, our original.
Right.
And we want to put it on the inside this time, but instead of going to the left, we're going to say plus 2.
But because you're going to the right,
sorry.
thank you.
I did it backwards.
Can we better change our little arrow up there, right? I don't think you meant it to go the right.
I did not mean it to go that way.
Right.
I meant that's...
Yeah.
Oh, boy.
I was confused.
Okay. So 2 units to the right would mean this way.
Yes.
Normally you would say plus.
But it's opposite of what you think. You just got to remember that. I know it gets confusing, but it's opposite of what you think.
Okay. So let's do the original one. Here's 0, 0.
And if we're moving 2 units to the right,
we just take our vertex, go over 2.
You're going to the left, though. We want to go to the right. Miss Boyd she really wants to go to the left today for some reason.
Okay. We're going to go to the right. 1, 2.
And we're going to draw the same shape.
Same shape.
Up, and it's going to cross the other one. What's the vertex of the new one?
We went to the right 2.
Yes.
And we didn't go up or down.
There's a new vertex. Very good. So maybe circle the rule, so they remember they have to write that rule.
Here's our rule.
Or highlight it. Yep, that's the rule. So you have to do 2 things here. Do the rule and graph if it asks you to graph.
Okay.
Okay. All right. So if we go to the next page, and we're going to go on. Oh, something a little bit, we're adding something, nothing different. It's talking about is the vertex form of the absolute value function. We're in a sense doing it implicitly right now.
Right.
So there it is right there.
Equation. They
talk about an H and a K. Well, the H is the horizontal movement.
Which makes sense. H, horizontal.
Yep. And K is vertical. So let's go on to this example right here. And maybe I should have Miss Boyd write the absolute value function.
Okay.
So f of x is equal to the absolute value of x minus h plus k. But I kind of messed up, didn't I? It should be g of x. Sorry about that.
That's okay.
We're both kind of messing up this video.
It's a rough day.
But that makes us more normal, right?
That's right.
Yeah.
So g of x
K
is the absolute value of x minus h
plus k. So what is h? What is k? Well, h is
our left to right, so that would be our
x value, and k is our up and down.
Y.
Right.
So I'm just going to write that here. H
is
x value.
Yep. K is the y value.
Y value. Okay.
So let's plug it into the formula.
Okay.
So g of x.
We got our g of x, and now we're transforming it since we're plugging it in.
Right. So we
leave our x.
Minus 4.
Minus 4. And now notice, we have the minus in the equation.
Right.
We plugged in a positive 4.
Right.
You just leave it.
Right.
You don't change the sign to plus.
If x would have been a negative 4,
then
we would have changed it. Okay. Exactly.
And then plus, in here, it's a negative 2.
Right. Okay. And you can write it like that or write it as minus 2. Either one is totally correct. Okay, so there's the rule.
Yeah.
And
so
now let's graph. So what we should do is graph. I like to graph the parent function first.
All right, so here's the basic
parent function. So it tells us what our new vertex is. So let's just go plot that point.
So
over 4.
1, 2, 3,
and down.
4.
Yeah.
Oh boy, and down 2.
Yep, there we go. And down 2.
All right, so over 4, 1, 2, 3, 4, down 1, 2.
Yep. And then just draw the same. Yep, there you go. So
you're going to be able to go backwards though too eventually. We'll give you this and we'll ask you what the new vertex is.
Exactly.
And so based on these numbers, you're going to have to know, oh, this is opposite, so it's really a positive 4.
Right.
Oh, here's our negative 2. Or if this would have been minus, you need to know that it's negative 2. Okay.
Exactly. So when it says translate again, translate means you're writing a rule. So maybe highlight the answer so they understand.
All right. So here is our new rule.
Yep, that's the rule, and then we graphed it.
Perfect.
Okay, that's example 3. And example 4 is on the next page. And we're not quite ready for example 4. Because what we've done right now is we've talked about moving a graph to the right, to the left, up, or down.
Okay.
You also can reflect a graph over the x-axis or over the y-axis.
Okay. If you notice the parent function, f of x, if you're reflecting over the x-axis,
what changes?
The negative goes on the outside.
And I want you to write a little note next to that. Yes. I want you to write y changes.
Y changes, yep.
And when you reflect over the y-axis, the x changes. So it's kind of the opposite of what you think. I mean, x, when it says reflect across the x, don't think, oh, your x changes.
Right.
No. Okay. Right. All right. And then one more little thing. When you're talking about a stretch or a compression, all that means is you have a number out in front of the function and you're multiplying everything by that number.
Okay, so stretch is always greater than 1. A compression
is less than 1. Exactly.
So if this number was like 1/2, we would know it's a compression. If this number was 3, we would know it's a stretch.
Right, but I'm going to throw something at you.
Yeah.
What if, what if A was a -3? Okay,
so the negative is on the outside.
Right.
Which tells me I'm flipping it.
Exactly. So I just want to make sure that students don't say, oh, -3 is less than 1. It's a compression. No. The negative in front has nothing to do with the stretch or compression.
No.
The negative only has to do with reflection.
So I'm going to write here fraction or decimal.
There you go.
Maybe that helps.
And you kind of think of it, you're taking the absolute value of A is what you're doing.
Yep.
Okay, let's do example 4. That's a good one. You're performing a transformation. So right away, you're getting a new rule.
Okay.
Then you're going to graph it. Okay.
I'm just going to put my parent.
I like it.
Okay.
So what we're going to do is we're going to reflect the graph of that function across the y-axis. So I want you to erase that red. Because notice we're not dealing with the parent function right now. Okay. It's not the parent function, but our given function now is different. Okay. We're going to be changing that function. We're going to be reflecting that across the y-axis.
Okay.
So what changes when we reflect across the y?
The x.
Right. So what we want to do is let's write our rule. So let's write g of x.
Oh, I don't like that color.
Okay.
G of x
equals the negative out front stays.
Yep, because that's just
because that would be, we would do something with that if we were reflecting across the x-axis.
Right. But we're not.
No. So now you do an absolute value instead of x.
We're changing our x now
to a negative x minus 4.
And then you just copy everything down.
Plus 3. Now, I need to tell you something because otherwise you're going to have a confusion when it's time to find the vertex here. Okay? When we look at the negative x minus 4. So what I would like you to do, Miss Boyd, if you could write underneath that g of x again.
Yeah.
Equals, and do the negative, do an absolute value sign. What I want you to do right now is I want you to do a negative sign, and then I want you to do a parenthesis, and inside there I want you to write x plus 4, and I'll explain it in a minute. Okay? Another parenthesis, absolute value, plus 3. Okay. The tricky part here is whenever you have a negative x, which we're not going to see that a lot in this chapter, but when you do, you have to factor out the negative because you can't find the exact perfect vertex otherwise. You can't.
So since you took this negative away, you have to
exactly. So now I can tell the vertex here. If we write vertex, the vertex of the red function, or I'm calling it the red, the vertex of the transform function, I should say, is now going to be negative 4, 3. Whereas looking at the blue function, we would have wrote 4. Okay.
But it really is positive because of the negative here.
So let's do this. We have a couple things we want to do.
Okay.
What's the vertex of the given function?
The original one?
That is going to be 4, 3. Right. So let's plot that.
1, 2, 3, 4, 1, 2, 3.
And we know which way is it going to go?
Well, it says it's going to reflect. Oh, it's here we have the negative.
So that means it's going
instead
down.
Of up, it's actually going to move
the negative
down
out front means it's reflecting over the x-axis.
Got it.
Now let's graph the transform function.
All right. So negative 4, 1, 2, 3, 4,
and up 3.
1, 2, 3.
And again, that's going down. Right. So notice what we just did. The blue graph, that was our given function. Okay. That was upside down, we call it, because of the negative out front. We reflected that over the y-axis. So we basically just grabbed it and picked it up and threw it across the y-axis, and it did a flip.
So if you like folded across the y-axis.
Yep, exactly.
Okay.
That's all we did. This is by far one of the hardest problems you're going to run across. And so, anyway, that's that example. Are we ready to move on?
Yes.
Okay. Example number 5 is
I
next.
think we should probably do these ones in class because our videos are already getting kind of long.
Should we do 5 and see, 6 isn't a graphing one,
Yep.
but I think we have time to do them in class.
Yeah,
Should we
I
just do
think
that? All right. So here's your video questions for tonight.
All right. See you tomorrow.
Bye.